Hi everybody, just a quick update on things on this channel. We have actually changed our name to BSV 10,000 hours. I thought it was more of an apt description for what we're doing and what we're focusing on this channel. You know, I've been working on trying to build our brand, and there's so many videos out there that promise that you'll learn, for example, Python in 4 hours, the basics, or you can watch a 10-minute video on blockchain and understand what blockchain is. We've actually so far demonstrated quite the opposite, which is like just to get through the basics of Python. That's been 17 hours of work. So that is in reality what it takes. And on this channel, we focus on the real learning experience. Which, speaking of learning, today we are going to be looking at Pandas basics. So we have moved on to more advanced topics. I'm just going to share my screen with you now. I took the liberty of preloading learnpython.org since I always have trouble loading it in my live stream. Okay, so I've never looked at this before, never heard of it, but we're going to see what Pandas basics are all about. Okay, Pandas data frames. Panda is a high-level data manipulation tool developed by Wes McKinney. It was built on the NumPy package, and its key data structure is called the DataFrame. So if you're not sure what NumPy is, you can watch our last live stream where we discussed NumPys in quite a bit of detail. Data frames allow you to store and manipulate tabular data in rows of observations and columns of variables. So we learned with NumPy, was it NumPy? Yeah, NumPy arrays. We learned that it's very useful specifically for performing like maths calculations, what would otherwise be tricky to do when working with a string of numbers. When we import the NumPy array, then yeah, it opens up a whole new world of functionalities, and we could work out the mean between two lists and what was highest and lowest, and yeah, so it was quite interesting. So this seems to be following along with that. We are actually, if you look at the learnpython.org website, we're in the section of data science. So DataFrame seems to be following along with that in the sense that it allows us to store and manipulate tabular data in rows of observations and columns of variables. So remember what a variable is, okay? It's the name that we assign to a value. So there are several ways to create a data frame. One way is to use a dictionary, for example. So I just want to see. So yeah, it's basically a panda is built on the NumPy package, and its key data structure is called the data frame. Okay. So in this case, we have a dictionary. Remember that we use curly brackets. And if I recall correctly, within dictionaries, we could store all types of objects. For example, lists, just normal variables, functions. So in this case, we've created a list of different countries. So Brazil, Russia, India, China, South Africa. Then we have, within this dictionary, we have capital. And then remember our colon. Don't forget your colon when you're writing out a dictionary. and we have another list. So basically it's the capitals of these respective countries. Then we have the area, and that's also a list, and the population, and that's also a list. Then we say import pandas as PD. So remember when we did NumPy arrays, we said import, I think it was NumPy, as NP. Now we're saying import pandas as PD. So it looks very similar actually to what we were doing with NumPy arrays. So now we create a variable. We're going to call it bricks. So these are actually the bricks nations. And we're going to say we've imported panda, remember, which is built on the NumPy package. So now from now on we can refer to it as PD. And then we're going to say .DataFrame. So .DataFrame and then dict, which is the name of our dictionary. So dict is in brackets, and now we're going to print bricks. Oh wow, okay. So basically it's printed out as a table. This is really useful. Like if you already know this type of coding, right? And let's say you work with data, then you can already start, I suppose, building your own tables and storing your information and starting to, you'll know from what we did in NumPy arrays, we can start doing stuff with that data. So that's pretty awesome. As you can see with the new bricks data frame, Pandas has assigned a key for each country as the numerical value 0 through 4. So Panda, So notice here we have a key 0, 1, 2, 3, 4. If you would like to have different index values, say the 2-letter country code, you can do that easily as well. So we would basically say then after this bricks.index equals. So remember this key looks like an index. Because an index always starts at 0, not 1. So we're using the dot index to now, it looks like, change these keys here, 0, 1, 2, 3, 4, to the abbreviations of the country codes. If we submit, it's probably, oh, there we go, it worked. BRRUINCHSA. Another way to create a data frame is by importing a CSV file using pandas. Now the cars.csv is stored and can be imported using pd.read_csv. So we still have to import pandas, and then we still create a variable. In this case, we're calling it cars. We're now referring to PD, pandas as PD, and then it looks like our code word is read_csv, and then cars.csv, print cars. So also we now know, like if you have CSV data, for example, a lot of us probably watching this channel are into crypto, and a lot of our reports or whatever of our transactions come in CSV format. So actually we have a way of being able to work with our transactions now within our own Python code. And basically we start by importing pandas, and then we use read underscore CSV, and then the name of our CSV file. I will double check that though with ChatGPT. Indexing data frames. There are several ways to index a pandas data frame. One of the easiest ways to do this is by using square brackets notation. In the example below, you can use square brackets to select one column of the cars data frame. You can either use a single bracket or a double bracket. The single bracket will output a pandas series, while a double bracket will output a pandas data frame. So I would like to check what is the difference between pandas series and obviously the data frame. So they say we would use square bracket notation. I don't know why they're saying cars per cap. Okay, square brackets. I'm just reading through all of this first, and then we will go into more detail. Square brackets can also be used to access observations, in other words, rows, from a data frame. For example, I see we have index underscore column. Well, what I can already pick up is normally like, think of a graph or even a table where you have basically two bits of information. And normally in a table, right, you have your headers, which is actually your columns, and then you have your rows. So in this case, the rows, unless we've changed it to the country codes like up here, it would just run 0 and then 1, 2, 3, 4, and so on. So if we want to get information about certain rows, we would use numbers, those numbers, unless we've specified otherwise. Or if we're looking for specific columns, it looks like we need to use the name of the column. So here we can see it's cars per cap and country. See here we're printing cars per cap. So whatever the name of your column is. You can also use LOC and ILOC, so lock and iLock, to perform just about any data selection operation. Lock is label based, which means that you have to specify rows and columns based on their row and column labels. iLock is integer index based, so you have to specify rows and columns by their integer index, like you did in the previous exercise. So cars.iLock2, so it's going to print index number 2, so it would be 0, 1, 2. It would appear to be item number 3. So it looks like there's no exercise for this specific section. So I think I understand the concept of a data frame. It's basically a table. So let's read over it again and try and now fully understand it. So Pandas is a high-level manipulation tool developed by Wes McKinney. It is built on the NumPy package, and its key data structure is called the data frame. So I would like to ask ChatGPT, Pandas, which is built does that mean all the tools that we could access in NumPy can be accessed in Pandas too? So maybe I'll do an exercise where we perhaps take a look at our, for example, some crypto transactions, and we see how we can formulate that or tabulate it. That could be quite interesting as something practical and useful. While Pandas is built on top of NumPy, it does not mean that all the tools available in NumPy are directly accessible in Pandas. Here are some key points to understand the relationship between Pandas and NumPy. Core dependency. Pandas rely on NumPy for numerical operations and efficient data handling. Many Pandas operations are built on NumPy functions and leverage NumPy's performance. So remember we worked out that NumPy was quite efficient and faster in terms of doing calculations than, like, for example, your ordinary list. Or if you had to do it on a list, not only would it be less efficient, but it would require more lines of code. Pandas provide additional functionality on top of what NumPy offers, specifically designed for data manipulation and analysis. It introduces data structures like DataFrame and series, which are not available in NumPy. So we're going to look at series. While Pandas uses NumPy under the hood, it doesn't expose all of NumPy's tools directly. However, you can always use NumPy functions within your Pandas workflow by importing NumPy alongside Pandas. That's good to know. Integration. Just by the way, guys, we should also fact check. So some of what ChatGPT says, so don't take everything here for granted. Here's a question here on Stack Overflow. So I think ChatGPT is correct because it says here, I found out accidentally that NumPy functions can be directly applied to Pandas data frames. For example, np.log mypandasdf works. This is not something that I expected to work since NumPy knows nothing about pandas. What is happening behind the scenes? So there was an answer here that Pandas is built in NumPy arrays, so it is working, mainly if numeric data. that is what ChatGPT informed us here. So pandas rely on NumPy for numerical operations. Lastly, you can easily integrate NumPy and pandas in your code. For instance, you can apply NumPy functions to pandas DataFrame columns or convert pandas objects to NumPy arrays using methods like .values or .toNumPy. So in this example, we have imported pandas as PD. We've imported NumPy as NP. We've created a variable which equals pandas, and we're turning it basically into a data frame. I'm curious as to the curly brackets. And then we've said dfc equals np.log. Okay, we haven't dealt with .log. This example shows how you can combine NumPy and pandas to enhance your data analysis workflow. While pandas extend NumPy's functionality, you can still access and use NumPy's tools as needed. In this example, why did you use curly brackets? So we used curly brackets here. If you look at ChatGPT's examples, and the reason is that the curly brackets are used to create a dictionary when initializing the pandas data frame. If you need to go back, it's probably a good idea to go and revise dictionaries. We have covered it. When creating a pandas data frame, you often use a dictionary where keys represent column names and values represent the data in those columns. Curly brackets are used to define a dictionary in Python. So we do know that. So let's just recall or remember or make a note that the keys like country, capital, and area are going to be our columns on our data frame. So think about that when you're listing your data or creating names for your keys. We have another example. They've already told us why curly brackets is because of the dictionary. In this example, so you can just look here, this example over here. NumPy functions are used within a pandas workflow. Here's a breakdown of the process. So we import both the pandas and NumPy libraries. We create a data frame using a dictionary. In this example, we created the dictionary first, and then when we created a data frame, so it's this pd.dataframe, we said in our brackets that it's this dictionary over here, whatever this name might have been. So we then create a data frame and we apply NumPy function. That's good. Thank you for explaining. So we know now the relationship between NumPy and pandas. Data frames allow you to store and manipulate tabular data in rows of observations and columns of variables. So rows These are your observations or your results or your specific unique data. Okay, and your columns are your variables, or in the case of a dictionary, your key. Note, area, and our key here is area. Capital, and our key here is capital. Country, and our key here in this dictionary is country and population. So we created 4 keys, and as a result, we have 4 columns. As you can see with the new bricks data frame, Pandas has assigned a key for each country as the numerical values 0 through 4. If you would like to have different index values, say the 2-letter country code, you can do that easily as well. So I see it referring to this as a key, these numbers here. So I'm going to paste this. Pandas has assigned a key for each country as the numerical values 0 through 4. Does Pandas do this automatically? When creating a data frame in Pandas without specifying an index, Pandas will automatically assign a default integer index starting from 0. Remember what an integer is. It's basically a number, but there's no decimal point. Sorry about that. This means each row in the data frame will have an index value, which is a unique identifier for that row. This index can be used to access or reference rows in the data frame. So that is quite straightforward, since my computer's asleep. So it's actually used the example that we're working with, more or less. And in this case, our dictionary is called data. And you see here when we printed our variable df, which is basically the Panda data frame for our dictionary called data, it's assigned it the indexes or the default indexes 0, 1, 2, and so on. So we always start from 0. So to access a specific index value, which remember refers to a row, these are all rows, then we use lock, and we actually cover that later on down here. So we would say df.loc, and then we always specify our index in square brackets. So 2 in this case would be Germany. If you want to specify a custom index, you can do so by passing the index parameter when creating the data frame. So this is one way of doing it, but they do show us here. We can say bricks.index equals, and then just remember when you're working with indexes, we use square brackets. So you're going to say equals, and then you're going to use square brackets. We could also have done it here, where, according to ChatGPT, where we here specify dictionary, we could also say index equals, and then I'll copy and paste this. Let's see what it does. See, so we can do it the moment we create our data frame. If you want to change the index values, you can do it straight away there. So that's very good to know. So if you want to access an index or a custom-made index, instead of putting a number like 0 or 1 or 2, you would just put in, for example, DE, whatever your custom name is. And I suppose that's useful because if you are using country names or you're working with countries, country codes are pretty standard, so it makes it easier, I guess, to be able to locate it. But otherwise, it's the same. So you would say df.loc square brackets and your country code in this example. We are going to take a short 10-minute break because I can see today's session is not going to be too long. I'll put a timestamp if you would like to later on just move on straight and carry on with the work. So I will see you shortly.
That's fine, bro. You're the person that we make fun of. We take you and we take your chart and we make fun of it. We put the two charts next to each other and we cuckold you and we say, look, we're banging the mad games.
Currency. Collectively, central banks are working to issue in a new system, and that means destroying the purchasing power of the currency and bringing down an entire class of people with it.
Characterize Bitcoin as a digital currency. You can call it digital gold. You can call it digital cash. You can think of it as digital money. You can think of it as digital property. You can think of it as digital capital. You can think of it as digital energy. You can think of it as a digital asset.
Government could just stop Bitcoin tomorrow. Liberty Reserve was shut down across 42 countries. Bitcoin can be like that, tomorrow banned. The way that they shut Liberty Reserve down was the Americans issued a financial services order. Anyone who took Liberty Reserve was banned from the banking system anywhere on earth. Basically, it means your whole company's wiped off the face of the earth. And they could do that, and they can do that to Bitcoin right now.
This is fun.
Welcome back, my knowledge seekers. Let's carry on with Panda basics. So, there are several ways to index a pandas data frame. Basically, data frame in this context is a fancy word for table. One of the easiest ways to do this is by using square bracket notation. In the example below, you can use square brackets to select one column of the cars data frame. You can either use a single bracket or a double bracket. The single bracket will output a pandas series, while a double bracket will output a pandas data frame. So if we look up here, we've got cars per cap, and it's basically just printed out, print cars per cap. So this was our first print. It's obviously printed our index, which is our identifier for each country. Now when we use two brackets, so that is a series, it prints like this. And then if we look at the further example, we say print cars per cap country. So I'm going to ask ChatGPT for some help. Can you explain to me the following explanation and example? And then let's just paste in the code. So when working with pandas data frames, you have multiple ways to index or select data. One of the simplest methods is using square bracket notation. Depending on whether you use single or double square brackets, the output will be different. A single bracket. When you use a single bracket, pandas returns a series. A series is a one-dimensional array-like object containing an array of data and an associated array of data labels, so an index. The double bracket, so when you use double brackets, pandas returns a data frame. A data frame is two-dimensional. It is a two-dimensional tabular data structure with labeled axes, rows, and columns. So, did I skip the CSV file part? I did. Anyway, we'll get back to that. So we have imported a CSV file. First, we started by importing the pandas library. Then the read CSV function is used to read a CSV file named cars.csv into a data frame called cars. Remember, it's a data frame because PD, we go up here, it said pd.dataframe. So it is a data frame just because of this line of code here, where we say pd.dataframe, and then in brackets we put in our arguments, or in this case our dictionary. The parameter index underscore col, as in col, equals 0, sets the first column as the index of the data frame. Printing a column as a pandas series. So we have print cars per cap. That is one of our, I would think it's a key. Using a single bracket to select the cars per cap column. This returns a pandas series, which is a one-dimensional array with the index from the data frame. Printing a column as a pandas data frame. So we would basically do the same thing, or say the same thing, except we'll use double square brackets. This returns a pandas data frame, which is a two-dimensional table. And basically doing that, you can actually print multiple columns. So we want to print cars per cap and country in this example, and it will return a data frame. Let's assume cars.csv has the following structure. So country, cars per cap, drives right. So I suppose drives like on the right-hand side. So we would import pandas as PD. We would create a variable called cars, which basically imports the CSV. We've basically created a custom index of 0, but let's just double check that. Yeah, the parameter index underscore col equals 0 sets the first column as the index of the data frame. Then we have single brackets, which basically prints a series. And then double bracket prints it as table or data frame. And in the second example, we do 2 columns. So the single bracket returns a pandas series of one-dimensional array-like objects. The double bracket returns a pandas data frame, a two-dimensional tabular data structure. So I do have a question, but I just want to go up here to the top. Is it necessary to do this? Basically, where we set the first column as the index. No, it is not strictly necessary to use the index col equals 0 parameter when reading a CSV file into a pandas data frame. However, using index col equals 0 can be useful depending on the structure of your data and how you intend to use it. Let's explore what happens when you don't use index col equals 0. When you use index col equals 0, you are specifying that the first column of your CSV file should be used as the index for the data frame. This is particularly useful if the first column contains unique identifiers, for example, country names, IDs that you want to use as the row labels. And then it shows us if we use the column method, it gives us the country codes, but if we don't, it still gives us the country codes. Oh, I see. If you do not use index col equals 0, The data frame will use the default integer index starting from 0, which basically means that the first column, this thing, it's trying to add to the answer and then it's throwing me off. And it's also freezing. So basically the integer numbers 0, 1, and so on will become a column. Just trying to open this here. My apologies, it seems to have frozen. Just give it a second. So we're going to see how we can use, to index a data frame, we can use single square brackets, double square brackets, and then we can also select data using LOC and ILOC. So lock and iLock. Out of memory. Okay. Hope we haven't lost our okay, we are back on ChatGPT. If you do not use index col equals 0, the data frame will use the default integer index starting from 0. And basically the difference is that the first column from the CSV will be treated as a regular data column. So you see here, this becomes now column. So I don't know, it might interfere with your calculations, or you really just don't want this information. You don't need it. What you really need is the country codes. When to use index col equals 0. Unique identifiers. Use index col equals 0 if your first column contains unique identifiers that make sense as row labels, for example, country names or IDs. It can make accessing rows by their identifiers simpler and more intuitive. When you wouldn't use index col equals 0, no unique identifiers. If your first column does not contain unique identifiers, or if it is just another data column, it might be better not to use index col equals 0. If the default integer index is sufficient for your needs, you don't need to set a custom index. So in this case, we have CSV content, which is basically your country, your cars per cap, and drives right. Yeah, so that's the so when you want to basically locate a specific column of data, or sorry, if you want to access a row, then in your square brackets using LOC, it might be easier or might make sense for you, instead of having to remember what number the US is in, to just be able to say it's the US that I want, because you know the different country codes that you're looking for. If you didn't, we can see here that the US index number 0, and to access the first row or the US row, you would have to put in 0, so you couldn't put in US. In summary, whether to use index col depends on how you want to structure your data frame and access your data. If the first column serves as meaningful row labels, using it as an index can be beneficial. Otherwise, the default integer index may be sufficient. So now we know why that's important. And then I just want to see here. So index call. So if you're importing a CSV and it meets the requirements, like in the example where it would make more sense to use the country codes rather than just random numbers that have no meaning, then you would basically input the index call function. My other question is, what is the purpose of the distinction between series and data frames? What is the practical purpose? Because there must be a reason why you can choose to use single brackets or double brackets. The distinction between pandas series and data frames serves practical purpose in data manipulation and analysis, as they are designed to handle different types of data structures and operations. Here's a detailed explanation of their purpose and when to use each. Pandas series. A pandas series is a one-dimensional array-like object that can hold data of any type, so integers, strings, floating points, etc. It is essentially a single column of data with an associated array of labels, which is your index. So the practical purpose of series. Series is ideal for operations on a single column of data, such as calculating statistics like the mean, the sum, or applying transformations. So I hope you guys are listening to this, because this is quite important to know when within pandas you want to use single brackets or double brackets. It all depends on what you want to do. You can, using series, you can perform element-wise operations directly on series, which is useful for applying functions to each element. I will get clarity on that. Since it's one-dimensional, series is simpler and often used for time series data, lists of values, or any one-dimensional array. Okay, they give us an example. So we basically created a list here called series. We then create a variable called S. After we've imported our pandas library, we take it and we turn it into a series, and then we can calculate the mean, or even we can add 2 to each element. So remember, when you have a list, each value in the list, be it a string, a number, an integer, a floating point number, becomes an element. A data frame is a two-dimensional tabular data structure with labeled axes, rows, and columns. It can be thought of as a collection of series objects, each representing a column. So the practical purposes of data frames. Data frames are used for data sets with multiple columns, allowing for operations across columns, such as grouping, pivoting, and merging data sets. Data manipulation. Data frames provide a powerful set of tools for data manipulation, including filtering, joining, and reshaping data. Complex data structures. They are suitable for representing complex data structures like spreadsheets or SQL tables, where each column can have a different data type. SQL, that sounds familiar. So it shows us some examples of operations we can do. When to use series versus DataFrame. Series. Use a series when dealing with single columns of data or one-dimensional arrays. Series are suitable for simpler tasks and individual column operations. So if you only need to work on operations, and let's say you're not looking to add the sum of two different columns, you actually just need to work out the sum of one specific column, then you would use series. DataFrame. Use a data frame when dealing with multiple columns and more complex data structures. Data frames are ideal for tasks that require multi-column operations, data manipulation, and analysis. This is interesting. So we can see here how we can convert between series and data frame. So to convert from series to data frame, so you see here we've used series and not data frame. You can convert a series to a data frame by wrapping it in a list of lists or using the toFrame method. So you would say series.toFrame, and then you say name equals column. Okay, we'll check that out. And then data frame to series, we would basically say, so in this data frame, you can see here we've created a dictionary. This dictionary has two keys. In other words, it's going to have two columns, A and B, and this is the information that's going to be relayed in the rows, right? So we can basically single out the column A by saying series equals, and then df square brackets A, which is our key. Remember, df is the name of the variable. The distinction between series and data frames in Pandas allows for flexible and efficient data handling. So just to sum up once again, a series is one-dimensional, suitable for single columns or lists of data, and a data frame is two-dimensional, suitable for multi-column datasets and complex data manipulation tasks. So let's just go up here. I did highlight something. So I just want some clarity on element-wise operations. What do we mean by I think I understand. So remember, when we're looking at series, think of it as one-dimensional, so it's one list. And that's basically what it is. It's a list of whatever is contained in that column. Now, when you think of lists, remember what I said, that each value in a list is basically an element. So what you can do is you can manipulate each element in that list. For example, the example it's giving us is we've created the series here, and then we are just going to keep, whoops, we're going to add 2 to each element, as it tells us here. So I see responses will use ChatGPT 3.5 until your limit resets. Okay, no problem. We're going to learn about lambdas. So I'm not going to look into that or stress about it. So let's just go back here. Simpler data structure. I understand this now. I'm going to ask for some examples of data manipulation. Has frozen again. Just give it a second. Sorry, guys. New. Give an example of this in Python. Data manipulation. So I'd imagine like filtering, or you could probably organize your data from A to Z. Here are examples of data manipulation operations using Pandas DataFrames. I wish it would stop doing this. Here are examples of data manipulation operations using Pandas DataFrames in Python. We will, what was I going to say? Oh yeah, we'll make notes on all of these. So filtering data allows you to select rows or columns based on specified conditions. So we have a dictionary here called data. We have 3 keys: name, age, city. It's a combination here of strings, integers, and some more strings. We have basically created a data frame of this dictionary, and now we want to filter it so we would say filtered underscore df. Remember, that's just a variable name. And then we would say df, and then in our square brackets, df, and then our Boolean is basically we're going to take the column or the key age, and it must only print the ages greater than 30. Remember that we must define df to be able to use it here in our filter. We can also combine data from multiple data frames based on specified keys or indices. So in this example, once again, we have a dictionary. We actually have 2 dictionaries. The 2 dictionaries have 2 keys respectively. We then create a data frame of data 1 and data 2. We would like to merge these looks like we want to merge df. So we create a variable called merge df, and then we would say pd.merge. We would merge df1, df2, and then there's something interesting here. On equals id, how equals inner. I don't know what inner is. We can also reshape data. So this involves transforming the structure of the data frame, such as pivoting or melting data. Pivot. These examples demonstrate some of the powerful data manipulation capabilities of Pandas, DataFrames, and Python. Depending on your data and analysis needs, you can use these and other operations to efficiently work with and transform your data. So I'm just going to ask here, what is the on and how in this line of code? Please explain it simply. The terms on and how are parameters used in the pd.merge function to specify how the merging operation should be performed. So on equals ID. This parameter specifies the column or columns to use as keys for merging. In this case, the merge is based on the ID column, meaning it will match rows from df1 and df2 where the ID columns are the same. How equals inner. This parameter specifies the type of join to perform. The inner join is one of the common types of joins in data operations or database operations. It combines rows from both data frames where there is a match based on the key column specified in the on parameter, ID in this case. Rows with non-matching keys are not included in the results. So on equals ID, we merge based on the ID column, meaning match rows with the same ID values. How equals inner means we combine rows where there is a match on the key ID in both data frames, excluding rows with non-matching keys. So in simple terms, on equals ID tells Pandas which column to use for matching rows between data frames, and how equals inner specifies that only matching rows should be included in the result. Great, so I've sought clarity on the types of operations we can do within data frames. So going back here, we had import pandas as PD. Then we have also imported at the same time a CSV. And then we have printed the column, specifically cars per cap, but effectively we're printing it out as a series, so not as a data frame or table. And if we go back up to the top, we've also specified that our column is 0. So remember why we do that, because we don't need the 0, 1, 2, 3, 4. What's important for us is the country codes. Then we can also print it as a data frame, which basically means we're printing it out as columns and rows, multiple columns. And we can print as many columns as we specify. So if there was another column here, we could just simply specify it in here within the double square brackets. In this example, square brackets can also be used to access observations. Remember, observations are rows. from a data frame. For example, up until now, we've been looking at using the columns. In order to do the rows or the observations, we quite simply just put in our square brackets and we can put in the specification. So print 0 to 4 or 4 to 6. So if I just restart this, let's submit it. And then I will just ask ChatGPT when accessing observations, do single, go series, brackets, and double data frame brackets also are. Because I see in this example, they've only used single double square brackets. The answer is yes. When accessing observations or rows in a pandas data frame, you can use both okay, let's just wait. That happens, we are going to just look at importing a CSV. ChatGPT's already explained it. We would just use read CSV as a function. Remember, if you want to use that CSV in the context of a data frame, you would import your pandas library. When accessing observations or rows in a pandas data frame, you can use both single brackets, which are series brackets, and double brackets, which are data frame brackets, and they have different effects. For the single brackets, when you use single brackets to access rows in a data frame, you get a series object containing the data of that row. That is similar to accessing a single column, but here you're accessing a single row. The index of the series will be the column names of the data frame. Index of the series. Oh, so we have our dictionary. We have 3 keys. We create a data frame, and then row series equals df.iloc1. We access the second row. Remember, the first row is always zeros when we're indexing. So the second row would be 1, and we're accessing it as a series because we're only using single brackets. If we use double brackets, it's going to print out the first and third rows. Remember, the first row would be indexed as 0. The second row, the third row would be indexed as 2 because it's 0, 1, 2. Return a series. So to summarize, the single brackets return a series containing the data of a single row. The index of the series is the column names of the data frame. The double brackets returns a new data frame containing 1 or more selected rows. Why a new data frame? because we create a new variable. In this case, selected rows. This is going to be our new data frame containing rows 1 and 3. This is useful for subsetting rows based on specific conditions or indices. Choose between single brackets and double brackets based on whether you need a series or data frame containing the selected rows from your data frame. Then I just want to find out but I wouldn't think so if just see if I can find it. Does this function exist except for observations rows, not columns? Observations. Okay. I'm just going to wait for it to do its thing. We can read on LOC and ILOC in the meantime. You can also use LOC and ILOC, so lock and iLock, to perform just about any data selection operation. Lock is label-based, which means that you have to specify rows and columns based on the row and column labels. iLock is integer index-based, so you have to specify rows and columns by the integer index like you did in the previous exercise. So whenever we use iLock, you're going to have a number, basically, which is your index number. In this case, notice we're using a single square bracket, so that the first print is going to be a series. Okay. As for the second print, we've used square brackets, but notice that we've also used LOC. In other words, we're specifying the names of the column label names. But we're also printing it as a data frame. So this will be tables and yeah, it will be a table. So columns and rows. Just reload. So I do know that. Yes, the concept of accessing rows and columns in a pandas data frame applies to both observations, rows, and features, columns. You can use similar syntax to access specific columns or rows based on your needs. To access columns in a data frame, you typically use the column name within square brackets or the dot notation. Use square brackets and the column name as a string to access a single column. This is a series. So this is another way of printing. Instead of using LOC, you can just create a variable and say df in your square bracket and whatever the name of your column is, and then you just say print. Dot notation. If the column name is a valid Python identifier and does not contain spaces or special characters, You can use dot notation to access a single column. Probably the reason for that is because of just general Python syntax. We don't use spaces and we don't use special characters. The only special character we use when we create names of variables, for example, a key name, like a column name, you can use underscore. And also remember that a variable or a key name can't start with a digit, like a number. So we could say name series equals df.name, and then we just print name series. So to access rows, we use iloc and loc, which is basically what we've just done. And we can see here how we can filter, use booleans to filter. So where the age in df is greater than 30, then print filter df. Or we can use slicing by specifying to print rows 1 to 2. Rows 1 to 2. This could be confusing because I see here it's not using our normal indexing. This looks like parameters, like start at 1, which is inclusive of 1, and stop at 3, which is exclusive of 3. That's why it's 1 to 2. In the example above, slicing, I see that the square brackets refer to parameters start and stop rather than indexing, which typically starts at 0. Is this true for Python? So we're going to learn something about slicing. So in Python, when using slicing with square brackets, the notation start stop does indeed refer to the parameters start and stop, and it follows a half open interval logic. This means that the slice includes elements starting from the start index. That's why it's, when we said 1 to 3, it includes row 1. But up to, but not including the stop index. So we went up to, we specified 3, but it's going to stop at 2. So we know about start and stop. Indexing, however, starts at 0. Then I just want to ask, isn't this also slicing? Except in this case, it's applicable to a column. So I'm a little bit confused. Because it's saying it's going to print out the 4, but in reality it should print out the first 3. That's odd. So I'm not sure if there's an error here on the website. I think this is something we would pick up practically though, if we were doing you would see like there's a problem. So I'm going to go ahead so that we can wrap up today's session. I'm quite excited actually as to what we can do with DataFrames. This is knowledge we can use just for everyday life to make your work easier. Don't save. Oh yeah, let me switch over to our notes. So we have learned about pandas basics, just in a nutshell, pandas basics. To put it in a nutshell, right? It allows us to work with data, and I suppose the just want to see here. One of the most important structures within pandas is the data frame. But we also learned that we have access to series. It ultimately boils down to how you want to work with your data. A data frame is essentially a table of different columns and rows. If you want to be able to manipulate or work with your data using multiple columns or multiple rows, for example, you want to add 2 rows or work out the mean of 2 rows, then you would use a data frame. A series is still useful within Pandas basics, but that's more when you're looking at doing a simple calculation on a single column or row. Now, essentially, we will recall that it's built on the NumPy package or library. So when we start, I don't think we need to import NumPy, but Pandas is also effectively a library. And it looks like the convention is to import it as PD. So we would say import pandas as PD. So we start with that step. Let me just open up a fresh page here. Then what would typically happen is we would have something like a dictionary. And remember when we did dictionaries, we worked with curly brackets and basically keys. So we start with equals. So this will be the name of our dictionary. It can be anything. And then we have a key like country. Okay. And then you just, it looks like that would be a string. And then you put in South Africa. So now if you want to turn, all of this into a table, you would basically say, create a variable, let's call it countries. And we would say equals Okay, pd.DataFrame. So remember when we were working with NumPy arrays, we would have said np dot, what was it? I can't recall. I have to double check. Anyway, and then in your brackets, you specify what you are now turning into DataFrame. In this case, it will be dictionary. And then if you print countries, it will basically format it into a table, which allows you to be able to do different things across different columns and rows of that table. Now, we also learned that at the time of doing this over here, so let's say this is our bracket, we can also say, if I recall correctly, it was, let me just check here, sorry guys, index underscore COL, and then you would say 0. And what that allows you to do then is to basically select or access a column using a preferred method or a more preferable method than just simply a number, an index number like 0 or 1. It might be easier and more practical to, for example, use the country code. So then in that case, you would use the index call function. There also appears to be another way to create an index, which is to take your, for example, you would say, in this case, our variable is countries. This is our variable name for our data frame. And you can say, maybe it's not in your CSV. You could say countries dot index and then put in your custom index name like BR, US, and so on. We also learned that in order to, you can import a CSV file, because remember CSV files are basically, it's a whole bunch of data, and it would make sense to be able to use it within a data frame. So basically the method we do that is we use read CSV, and then you would say the number of your CSV file. So it could be cars.csv. Just remember that in the front of this, you would create a name for it. So cars. Going back to what we discussed earlier in this note taking, we talked about data frames and series, and basically the different way to access data or represent it would be to use square brackets for a data frame, double square brackets. If you just want the information as a series, you would use single brackets. So for example, you want to say print cars, but I assume you would also maybe want to create a new variable where you maybe choose specific columns to create a data frame within the data frame, if that makes sense. And then remember, we're using double square brackets, whatever the name is of your column. Okay. And then end off with double square brackets. And don't forget to end off with your round bracket because we're printing. The same thing would apply here basically, except that you would just use single square brackets. And then lastly, we learned about LOC or lock and iLock. So for example, if we want to print cars, we would say cars dot LOC. Then we can choose double square brackets, single square brackets, it doesn't really matter. But within here, you have to actually specify the label of the column or the row. So whatever the name it may be, like countries. Whereas with iLock, so instead of saying dot lock, you would say iLock. It's index integer based. So what would go in here is not your label, but your number. For example, 2. Not just any number, it's an index number. Okay. That's it for today's video. Tomorrow, we are going to be looking at generators. I hope this was a good learning session for you. And I'm excited to see what we can do with DataFrames. So let me know how you can apply it personally to your life to now make it easier and automate certain aspects, either in your working life or your personal life. Otherwise, my knowledge seekers,